How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at some practice problems for metals, nonmetals, metalloids, and group trends. All right, so question number one, which of the following elements is the most metallic? So we know that metals are on the left side, so the most metallic towards the left. And you can see that in like period 2. We got definitely a metal, and then we end up with non-metals on the right side. So left to right, metallic. And then also from top to bottom becomes more metallic, and you can see that really in like group 16. We got oxygen, which is a non-metal, and you keep going, but then you hit a metalloid, and then you hit a metal. So most metallic we're talking about to the left and towards the bottom. So which elements do we have to pick from? Well, we got sodium. Where's my pen? There we go. Sodium, barium, magnesium, calcium, and cesium. So of the options, the most metallic would definitely be cesium. All right, number 2, which of the following elements is a metalloid? So you can see in the image here, it's the ones that are color-coded in brown, right? So we got boron, silicon, germanium, astatine, Sb, Te. So which one of these? Well, let's see. Pb, nope, that is just a straight-up metal. Bromine's a non-metal. Ge, yes. Sulfur, nope, that's a non-metal. Carbon, nope, that's a non-metal as well. So there you go. Number 3, which of the following elements is the most metallic? Again, most metallic, we're going to the left and towards the bottom. So what are our options? We got potassium, we got magnesium, we got sodium, we got aluminum, and we got argon. So the most metallic, well, let's see, most to the left and towards the bottom we got is potassium. Okay. Number 4, which of the following elements is the least metallic? So again, we know metallic characters increase going right to left as well as top to bottom. So least metallic, we want to go all the way to the right and towards the top. So let's see what our options are. We got sodium, argon, magnesium, potassium, and aluminum again. Well, hey, argon is the only non-metal of our options, and it's a noble gas. So it's non-metallic. The least metallic one would be argon. Why is carbonated water acidic? Because whenever you have a non-metal oxide and you react it with water, you end up with an acid. So non-metallic oxides in water are acidic. And that is one of the big issues with like acid rain. We're burning all these fossil fuels. We put out these non-metal oxides like nitrous oxides as well as carbon dioxide. When rain comes down and interacts with those gases, it produces an acidic rain. 6, which of the following elements would be expected to have the following properties? So it looks like a metal. All right, so we're looking for something that's metallic. Poor thermal conductor, well, that's kind of a non-metallic property, and acts as an electrical semiconductor. Well, that's like a metalloid kind of property. Semiconductor, it means it kind of conducts like a metal does, but also it doesn't really. So let's see, silicon, one of the most famous semiconductors. So that's probably going to be our best option, but I could be convinced, maybe if you don't know much about Ge, and you're like, well, I know it's a metalloid, I'm gonna go with that. I would also take that. I wouldn't knock you. And then you'd probably also say like, well, what about astatine? I'd be like, you could make an argument for that, but you know, boron, like you could make an argument for that too. Tin, definitely not. Best answer is going to be silicon. That's the most widely understood being a semiconductor. So I'll go with that one. 7, for an element with a valence electron configuration of ns2 and p5, which of the following statements are true? So if we're talking about ns2 and p5, we're talking about 7 valence electrons. So we're talking about things in group 17. Are they expected to form anions with a charge of -1? Yeah, that's true. Are expected to have large positive electron affinities? No, they want to be negative. They give off energy when they gain electrons. Are they nonmetals? They sure are. And do they form acidic oxides? They sure do. So which one of these would be 1, 3, or III, and then IV. So 1, 3, and 4 are true statements. 8. Which of the following elements is more reactive than magnesium but less reactive than potassium? So if we take a look, let's see, what are our options? We got beryllium, sodium, rubidium, calcium, and francium. So less reactive than potassium. So when we talk about metal reactivity, it is the greatest to the left and then also towards the bottom. So if it's more reactive than magnesium, we want it to the left and down. And then less reactive than potassium, we want it to the right and up. So what options are there? Well, let's see. To the right and up of potassium, well, it could be sodium or beryllium. And then more reactive than magnesium, though. So either to the left or down. Well, to the left is sodium. So sodium going to be our best answer. But wait a minute. More reactive than magnesium. Calcium's expected to be more reactive than magnesium, but less reactive than potassium. So yeah, we got 2 good answers there, right? Because it's to the left, it's to the right of potassium, which makes it less reactive than potassium, and it's below magnesium, which makes it more than that. So yeah, you got 2 good answers here. 9, alkali metals tend to be more reactive than alkaline earth metals because why? All right, well, if we take a look, alkali metals are not more reactive than alkaline earth metals. That's not true. Group 1, definitely more reactive than group 2. Alkali metals have lower densities. That doesn't really have anything to do with reactivity. Alkali metals have greater electron affinities. That's not true. Alkali metals have lower first ionization energies, or yeah, that's why they're more reactive. It's easier to remove those electrons. And alkali metals have lower melting points. Nothing to do with reactivity. All right, element X reacts with oxygen to form an oxide with the formula XO. When XO is dissolved in water, the resulting solution is basic. So, well, hey, if it's basic, I know that must be a metal oxide. So it's some sort of metal with the oxide ion, and if it's XO, well, oxygen I know is going to have a -2 charge, which means that metal has to have a +2 charge. So I'm looking for something in group 2. Best answer looks to be barium, the only option that is in group 2. I guess that's it. Hope you found it helpful. I'll see you in class. Okay, bye.